Hello, everyone. My name is Sid Shibiraj. I am part of the product management team at Google Cloud within the cloud network security team. With me, we have a remarkable set of speakers. We have from different perspectives as well. We have a customer in Olivier, we have a partner from Broadcom in Toby, and we have our engineering leader, Ashok. We will be talking about network security challenges. We'll be talking about use cases, practical applications, and even showing some demos. We'll start off the session with an overview of network security challenges, and I'll also introduce some of the Google Cloud native products that address these challenges. We'll then have Toby come on stage and talk about one of the integration use cases that we've been working with Broadcom on. Then we'll have our customer, Olivier from Symphony, who will talk about their cloud journey and experience. And then we'll conclude with insights from our engineering leader, Ashok, who will talk about how we are reimagining the network security solutions that we develop within Google Cloud. As you can see, and you all know that you're moving a lot of sensitive data to the cloud. You're moving critical business applications to the cloud. It's becoming very ubiquitous. Still, when we did a research with many organizations using TechTarget's ESG, 88% of the organizations said they're still struggling with security for this infrastructure. Now, additionally, attackers obviously know this. They're targeting this infrastructure, right? You have things like zero-day exploits, you have malware, they're opportunistically using misconfigurations in the cloud environment. So all of this is really adding up to the evolving threat landscape. And then you also see that on an average, a typical organization is seeing 60,000 attacks a year, and that is costing them millions of dollars in remediation and protection. Now, add to this, to make matters worse, you have applications that are becoming more and more complex. You have applications that are not just crossing region boundaries. You have applications that are across clouds. You have applications that are exposed to the internet. So this is really becoming complex and challenging from a security perspective. In fact, 94% of the organizations in the same research said that they have applications that cross regions. 79% of these organizations also had an application exposed to the public internet. What all this really means is organizations need a simple, highly scalable, and high threat efficacy based network security solution so that they can address this challenge in a complete fashion. And that's exactly what we'll be talking about in this session. We'll talk about how Google Cloud network security products are addressing this. There are three main use cases when you think about cloud network security. First, you have protecting the distributed application infrastructure. So think about securing app-to-app flows, app-to-internet, app-to-on-prem, application to the internet flows as well. Then you also have, next, you have the global front ends, right? So you have these applications that are exposed to the internet, so you have to worry about securing them against threats like DDoS attacks. And finally, you have protecting the hybrid workforce. This is securing the user-to-application communication using tech stacks like SSE or Secure Services Edge. In this session, I'll be mainly focusing on the first use case, but please plan to attend SEC 219 and ARC 301 for more details on the use case 2 and use case 3. Now let's dive deep into the distributed applications use case. In many of the conversations I have with customers, you've indicated that you're building applications that cross cloud boundaries across many clouds. You're picking and choosing the best suited components and managed services from different cloud providers. While this is providing probably agility as well as time to market benefits for application developers, the network infrastructure that is hosting this application and also that has to deal with the traffic that is traversing across clouds raises many security concerns and challenges. And with this in mind, we have introduced multi-tier, multi-layered security to address this challenge. We have two key components that I'll be talking about in this session: Cloud Secure Web Proxy, which is an egress web proxy specifically securing your egress communications from workloads to internet or SaaS destinations. And then you have Cloud NGFW, which is our distributed firewall service that is built into our network fabric. I'd like to start off with Cloud Secure Web Proxy first. So this is, like I said, mainly to make sure that any communication that is from your workloads on an egress path is only going to known and authorized destinations. Right? Additional benefits also include it's a fully managed service, so you don't have to deal with setting up VMs, scaling VMs, or anything like that. You don't have to also worry about managing things like squid proxies. All of those can be completely replaced with the solution. Additionally, it gives you very rich HTTP and HTTPS logging, so you can use it for things like compliance, audits, for incident response, and forensics. You also have granular security policies that you get through this product as well. So that can be used to make sure that you're only accessing the right destinations. And I'll go a little more detail on this subject in future slides. Let's look at what's new in this product area. First off, we are starting with inline network DLP. We are pleased to announce a partnership with Broadcom, where we are bringing semantic DLP's capability and integrating that with Secure Web Proxy as well as Google Cloud load balancers. This is going to help you safeguard sensitive data in transit from accidental or malicious exposure. Now, the other two use cases that we had, I'll be talking about them in more detail, but I want to bring Toby on stage to talk about DLP integration.
Better now? All right. So for the next couple of minutes, we talk about DLP. So when we think about, and Sid pointed out before, is workloads are moving to the cloud. When we think about DLP, the important thing is, while DLP is user-centric, there's also the workloads where eventually machine-generated data needs to be secured, data that is traversing from maybe one application zone to another one. And that's really where the integration with Google comes in, but a challenge that needs to be solved. The second part is around productivity. Productivity has a few angles. One of the angles is the data security and the DLP persona. Why is that important? Think about all of the tools today that are out there with your DLP for email, your DLP for web, your DLP for workloads, your DLP for endpoint. All of those tools need to be managed. You need to have a consistent experience in terms of detection, but also in terms of incident response, because you don't have the amount of people that you need to train for different tools for incident response or policy tuning. But then there's the second part to that, and that is around the actual detection in itself. If you have different tools, it is very often the case that you have also different detection results. And that is very critical from a DLP standpoint, where it's all about compliance, making sure that you don't lose any sensitive data or give any unauthorized person access to it based on the same classification. And then the last part is around really compliance, really around safeguarding your data and kind of the tools that are being used to have a consistent result. Because in the end, you want to make sure that your data stays within your perimeter if needed. It could be intellectual property, but obviously from a compliance perspective, ever-changing regulatory mandates like PCI, HIPAA, GDPR, and so on. So when we think about the first challenge really, and this is where the collaboration with Google has helped us to actually integrate into the network services, our leading DLP service, to provide consistent experience into the workloads around EDM, IDM, our vector machine learning technology to really help our customers to expand the existing DLP portfolio that they have across all of the individual vectors already, but also with SDI to make it very easy for any of you to get started with clear data identification, being east-west or north-south communication, as Sid pointed out, being eventually cross-region data that shouldn't transfer into other region, or just data to the internet where unauthorized users have access to it. We offer a wide range of data identifiers, policy templates that also helps with a lot of the regulatory mandates related to detection for like GDPR compliance and some of the other areas like HIPAA for our healthcare customers. The next part is around the productivity aspect. The things that I mentioned before. Do you want to train a lot of the incident responders on different tools? We have, with our unified management, the capability through either cloud delivered or on-premise delivered, if you want your data sitting on-premise, providing integration into, let's say, Google Workplace, into now Google GCP through the network services, or securing just the email stream or data in your own data center with a unified DLP policy, same detection response that you would get through the same detection engine, which is really crucial when you think about enforcing the DLP policies across all of your data estates. And then finally, also providing unique workflow integrations for all of the DLP channels that are integrated, being the endpoint, being in your data center, or now into the Google workload. So for the integration, there's a few examples. The first one I want to start with is the SWP integration. In this scenario, we have a few components. One of them is really zone A and zone B, which you can also put those zones into different regional zones. This is where eventually the east-west scanning becomes important, because for me, as a European citizen, maybe my data should remain in Europe and not go to North America. So you want to make sure you know what data is traversing between different zones. But then also, more importantly, data that is going north-south, stuff to the internet, where you lose eventually control of your data assets. And that's where the integration with the SWP is very crucial. How are we going to do that is because of the new capabilities Google offered through the callout extensions that allows us to hook into our DLP service into SWP. In that situation, what can be done is obviously just monitoring the data or also blocking the data. The second scenario is just reverse it with a load balancer, application load balancer architecture. Think about a very simple content delivery network, right? You have your store backend on one side, and you have your devices, could be a mobile device, could be a desktop device, unmanaged devices, managed devices, all different criteria that you access your content delivery network. And that is being accessed through a load balancer, as Sid pointed out, for various security reasons. That's also where the integration point then sits with the DLP service to allow you to scan content based on all of the attributes. You cannot download on an unmanaged device, or you can upload non-sensitive content to the backend of the content delivery network because of that integration. So in the next couple of seconds, I have a video for you which basically demonstrates the integration into the application load balancers through the callout extension. So what that means is we have here our load balancer front end that is configured and hit a web server. On the next one, we see basically the new callout extension that is being used that now integrates and sends all of the data streams into the DLP service when it triggers the load balancer. In the test scenario, we have a very simple web server on one side, and we have Postman on the other side. And if we send a request with a clean file, which we do right here, we see 200 OK, which basically means file has been posted. Could be any graphic front end whatsoever, but it demonstrates the use case. In the second one, we have a file that is obviously not clean. And as you see, the file is getting blocked. The message can be completely customized, but also obviously with any application design can be customized depending on application use cases or escrow concepts, whatever you have. But more important then, when we bring it back to the DLP administrator experience, is that unified console that harmonizes all of the attributes required to make decisions on, was it a malicious incident, or is it something that is happening based on a business process, with all of the contextual attributes that are available, either from a DLP standpoint, but also from an application context that can be extended depending on the applications that you have. And in this case, as you see here, it was the file that was blocked based on a simple keyword rule, but obviously other things are possible. And with that, I'm going to hand it over back to Sid to walk you through some other use cases.
Thanks a lot, Toby. That really demonstrated the power of bringing data security in line with secure web proxy as well as with our cloud load balancers. I quickly want to also talk about two additional use cases. First, I want to talk about the security for GCP workloads to internet egress. Typically, what we've seen with customers here is they want to centralize their egress security. So they want to deploy the secure web proxy in a hub and spoke fashion potentially. And what the advantages that you receive with this is, A, you have now a single place where you can do all of your monitoring and all of your visibility and kind of auditability, right? Second, what it also provides you is the granular security control can now be used to make sure that only authorized connections are taking place. Now, what do I mean by granularity? It can be at a source level where you can use service identity, you can use secure tags or IP addresses. The policies can, at the destination level, can have full URL paths, it can have wildcard URLs, host names, and also the policy can leverage any request header or request method. So you can get really, really granular and bring in zero trust implementations into your security policy to make sure there is no unauthorized access. The next use case is for securing GCP to on-prem traffic. This is actually becoming something of a new use case for us where we are seeing some financial sector customers where they have cloud workloads that are reaching out to backend service APIs that reside on premises. Now, typically, this goes through something like an API gateway like Apigee that provides API discoverability, reliability, and so on. But now you can also send this API traffic additionally to your secure web proxy to ensure that the workloads are only connecting to known and business sanctioned APIs. Next, let me go into the next generation firewall as an additional security product for network security. Cloud NGFW is built on a distributed architecture. So you are now bringing your security inspection and control as close to the workload as possible. It is operationally very simple because you have transparent insertion. You do not need any routing changes. And it also now brings network security posture management features like hierarchical policies, secure tags, as well as firewall insights. Hierarchical policies provide you the ability to create and enforce very consistent security policy across your organization. Secure tags provide you granular identification and microsegmentation. Firewall insights can leverage ML-based metrics to help you optimize as well as monitor your network security posture. At previous Next, we announced the preview of Cloud NGFW Enterprise, our top-tier offering. It was a very well-received preview. In fact, it was the largest preview we have had till date in the cloud networking portfolio. So it shows very high customer demand and interest in this product. And I'm very pleased to announce that it is generally available starting today. Cloud NGFW Enterprise is built on the same distributed architecture, so it gets all of the benefits I just talked about, and in addition adds intrusion prevention capabilities using Palo Alto Networks technology to identify and block malicious traffic such as software exploits, command and control channels, and malware. It also provides built-in TLS inspection capabilities, so now you can decrypt and inspect for hidden threats within your encrypted traffic at scale. There is a dedicated session on this topic tomorrow, Sec 301, where we'll be going into migration journeys, use cases, and also doing a demo of all of the cool features and capabilities of Cloud NGFW. So please plan to attend that. In the beginning of the session, I kind of laid the groundwork, and I said that, hey, there is this evolving threat landscape that is impacting and making network security hard. One of the other things that I am also hearing from a lot of customers is just a shortage of talent, right? You have, if you take an example of, let's say, vulnerability detection and protection, you have on one side, you have security teams getting thousands of alerts from their network sensor. And on the other hand, they have a long list of vulnerabilities that actually impact their environment. There is no easy way to correlate these two, and how do you decide what alert to prioritize, what patch to prioritize from a software perspective as well. And that's where you will hear, again, across all of the sessions, how we are infusing the power of Gemini across our products in Google Cloud. And this is one such use case where we are able to use the power of Gemini to simplify this procedure and really help you save valuable resources and time. For example, let's take an example scenario that you have a critical vulnerability in Apache that is impacting your environment. First, you want to understand what VMs or workloads in your environment are impacted by this vulnerability. So you'll go ask Gemini what VMs are exposed to CVE XYZ. You will get a full list of all of the workloads that are impacted, and also you will see what the vulnerability is, what is the criticality, what's the CVSS score, and get a lot more details about the CVE. Next, you would want to understand if you're seeing active exploitation attempts for this vulnerability in your environment using the NGFW threat logs. So you can ask Gemini, are there active exploitations? And it will tell you these are the latest threat attempts that are seen for the CVE. It will also give you details of where this originated from, when it happened, and what the action that was taken, whether it was dropped or whether it was allowed, so you have more context. You also can use this IP address for further incident response, and I'll come to that. But let's say that you are running the NGFW in a detection mode instead of a prevention mode. So you now want to understand how do you modify your firewall policy to now block this threat, right? So you can go ask Gemini, what is the modification needed to my firewall policy? It will give you the gcloud command that you can take. You can run this in your environment and modify your firewall policy. And finally, you also want to understand what is the scope or the full impact of this threat, right? Where else has this malicious source been communicating with? What other environment is impacted? So you can potentially now go take that source IP address, look up your VPC flow logs to figure out what other communication has happened to this source IP address. Now you can get all of those details. You can use this forensics, and you can also do quick incident response based on this. This shows the power of Gemini of how you've taken a simple vulnerability detection and response use case, which can be very complex and time challenging, but you've reduced it into a few easy steps where Gemini has taken all of the heavy lifting. Now, let me talk about a few common deployment patterns with Cloud NGFW. One of them is using network virtual appliances. You usually use some sort of route manipulation, and you have also usually customers run into challenges with this scenario where they have to do lifecycle management, scale management, routing updates. So typically, what we would ask customers to do is do a full migration into a Cloud NGFW-based architecture, because that significantly reduces all of this, right? These challenges. But we do understand that sometimes you're not able to do this full migration. So first, let me talk about a partial migration, if you will, on how you can improve your security posture in a completely non-disruptive way, right? As you can see here, you have your distributed firewall rules that have been implemented for your workloads with no routing changes and completely transparent. And immediately you have better security posture because on your left, you were only doing perimeter security or inter-VPC security. Now you're able to do both inter and intra-VPC security. Now let's take a look at how do you migrate your north-south flows to Cloud NGFW-based architecture. First, let's look at the NVA example. For egress, typically what happens is you have a workload in VPC A that wants to communicate to the internet. So this, through some static routing, has to go through your internal network pass-through load balancers. That is then sent to your network virtual appliances for inspection. You have to do a source NAT and then send that to your destination. For the return traffic, this comes to your global external load balancers. Then you have to bring it to your network virtual appliance that may be running in typically an active-active kind of HA deployment. Then that gets sent to the actual backend, which is your workload. So you can see all of the complexity that goes into this. Now, when you look at how you would do this with a Cloud NGFW-based architecture, you would first have Cloud NGFW firewall endpoints in all of the zones where you have critical workloads. You would then add VPC network. You would kind of add this firewall endpoints and match it to the VPC networks that you have. And then you would basically also add your firewall rules and update them. Then you have source NAT going to the internet. Now, on the return path, again, as you see for the egress, no load balancer, no static route changes, none of that, right? For the ingress path, you'll come to the global load balancer, but now the backend is actually your workload. So automatically, the data comes to your workload directly, right? In the left-hand side, one thing that I did not mention was for your ingress path, your NVAs have to also do source NAT and destination NAT because you can have asymmetric flows potentially. Again, in your Cloud NGFW architecture, all of this complexity does not exist. And then you can have VPC peering to make sure that any of the VPCs, any of the workloads can talk to each other. So completely transparent insertion, easy to deploy and manage, and you get full visibility as well. Similarly, for your east-west traffic, it's simple. For your NVA example, you basically, similar to your internet egress, traffic has to go through some sort of static route manipulation to go to your pass-through load balancer. Then instead of going through, you don't have to do source NAT in this case because you have Google Cloud supports symmetric hashing, so it automatically knows which flows this has to be sent to, so it goes to the correct backend workload. Now, on the Cloud NGFW side, you actually have to do nothing because you've already set it up for the north-south flow. The workloads can already talk to each other. So automatically, the NGFW firewall rules apply. Almost no change required at all. Now, I'd like to bring Olivier, and folks, you have to give him a big round of applause because he has come from south of France to be here for us to talk about his Google Cloud journey.
Thank you, Sid. Can you hear me? So thank you for hosting me. I'm Olivier Richaud. I work for Symfony, and I lead the SRE and technical platform engineering. Symfony has been out for a decade. Our industry is a financial industry, so we are a fintech. We evolve in a highly regulated environment, so it means that we need to be secure, compliant. Our solution is used in very precise and important workflows to ensure communications and secure, compliant communications. So it can be chat system, it's where we started. It's collaboration tools, workflows based on this chat system, and voice, trading voice for trader voice for people on the trading floor. So it's highly regulated. We ensure that everything gets audited, everything is recorded, and we offer API and on top of this platform to access the platform and operate. So this is it for Symfony. Let's go back to this session and the specific case of internet egress traffic, and some thoughts around that. First of all, it's completely normal to control outgoing traffic. So egress filtering is very important to us. We cannot have workload accessing SaaS services or distant remote services without any control. We need to have control over the data or malicious traffic that could bring this data outside our estate and leaving the perimeter that we control or attack a perimeter that we don't control. So typically, we use SaaS services for mail delivery, things like that, so we need to have a full control over that. The second parameter that we need to take into account is we have multiple types of workloads. We have VMs. That was 5 years ago what we were using. We have not decommissioned everything, but we still have VMs with Google. We have Kubernetes engine workload. But we need to have something which is equivalent, ubiquitous for all the estate. And frankly, Sid, you mentioned that. Squid has been around for quite a long time. I've been in the business for quite some time, more than 2 decades. And Squid is the perfect solution. A proxy is the perfect solution if you want to get control on your outgoing traffic. So really, most of the applications support proxies. I know that there are some specificities for proxies, but it's not rocket science. So we are not discussing AI or very advanced tools. We are discussing very common tools to secure outgoing traffic. So our initial design before Secure Web Proxy, and you'll understand why we wanted to migrate, and we migrated to Secure Web Proxies. So we need to maintain a set of IP addresses that we need to reach out, and we need to maintain at the same time the network policies in our estate to control the traffic, the outgoing traffic, and the firewall. So what we did, we invested in building operators in the sense of Kubernetes operators, and we managed DNS resolutions, HTTP calls, and so on and so forth. So we had to maintain the network policies. We want 2 operators and the firewalls. And guess what? You had to maintain the consistency between the firewall rules, the network policies, and all those IP addresses. So you have no logical isolation. You manipulate the raw IP addresses, and guess what? The IP addresses, they changed, and the DNS resolution time is longer than the time you make the change. So we cannot afford a solution which is such brittle for our outgoing traffic, and we don't want to have no control over the outgoing traffic. So today's architecture, simple answer, no more operators. That was a nightmare. That was answering the question. That was a valid answer before Secure Web Proxy. But now we have all our outgoing traffic directly directed to the Secure Web Proxy. So simple network policies. For egress traffic, you go to the proxy. We don't have to manage IP addresses consistency between firewall rules. Everything is logical. We have logical routes for that. And the only exception we made is that we don't enter the TLS termination in the Secure Web Proxy for various reasons, and we whitelist the domains we want to target. The challenge I mentioned at the very beginning was for that, you have to have your application proxy ready. I mean, they need to support a web proxy. So if you run very old versions of application or Java versions, you don't have this control, so you need a bit of upgrades if that's the case. But frankly, we didn't have this situation. And that was the only caveat we found for the solution. So in a nutshell, we have something which is simple, the same for whatever workload we address. We don't have serverless, but that will work the same way. We have a simplification, and we are much more secure because we have a single point of control for all the outgoing traffic. And with that, thank you for your attention, and I leave the floor to Ashok.
Thanks, Olivier. Hi, everyone. I'm Ashok Narayanan. I'm a tech lead on the cloud networking security team. And I wanted to talk a little bit about some of the engineering innovations that we're building in order to achieve these aims. So we've talked about the fact that it's important to Google. We believe that security lives in the network fabric, right? As a customer, you shouldn't have to steer your traffic manually to a set of choke point entities and provide perimeter security. That's not our vision. And so the distributed firewall has offered connection-oriented stateful security in the fabric, but I think we know that in today's landscape, there's a set of security functions, especially expensive ones that involve AI/ML, which can't be executed in a distributed fashion. They actually have to be executed in a centralized set of services, a set of VMs. So we closed this gap by extending the Andromeda SDN data plane. So Andromeda, as many of you know, is our underlying SDN data plane that powers GCP. That's published in a paper at NSDI in 2018, where we talked about it's a multi-stage forwarding pipeline, but it has essentially two tiers, a high-speed packet forwarding path, and then a set of local co-processors for more expensive processing. We have actually extended this now to 3 tiers, where now there's a third tier which actually runs off-box. We're able to deliver packets from Andromeda, from the hypervisor, for extra processing if it's needed to a set of engines. And we're also able to do this in a consistent manner, so packets in related flows in both ingress and egress directions from a host go to the same node for processing. Cloud NGFW security is the first use case where we're actually productionizing this for our customers, where you can configure in a distributed firewall policy certain microflows, which will then be delivered to our security engines. And the security engines that we are supporting today are transparent at-scale TLS interception managed by GCP, as well as malware and threat protection driven by AI/ML powered by Palo Alto Networks. Now, because this is built into Andromeda, it doesn't override the underlying routing, forwarding, connection tracking, or load balancing semantics of the original VM. So one of the issues traditionally is that when you are collapsing traffic from multiple VPCs and multiple sources into a single set of security processing engines, those engines then need to forward those packets in a way which the original VMs would have. Or you have to collapse your network and change your routing rules. With this architecture, since the security processing and the routing are actually split in the SDN stage, we don't actually affect the routing. So you don't have to worry about renumbering, trying to carry special state in order to create special policy routes. We also are offering this, or will offer this soon, for third-party integration. At L3 or L4 firewalls, we're centralizing around Geneve as a standard protocol for this, and we have a set of partners who we're working with. And then at L7, we already talked about our investment in Envoy to build the secure data plane extension protocols, basically built around gRPC. And so we're going to continue to offer at L3 and L7 a way to insert security services without forcing you to route traffic to them. So another issue that I think we've all seen is this problem of a zero-day workload. Today, the barrier to entry for a developer in any of your organizations to turn up a VM, create a new VPC, try out a new AI service is very low. And we think that's a good thing, right? Because the more your developers are able to experiment, the more they're able to deploy new services, the more business velocity you have. But of course, this makes a large number of hyper-segmented VPCs, applications, and cloud networks. And it means that this CUJ of how do I protect the first packet sent from a VM? How do I protect the first packet received in a VM? Right? That becomes complex. The traditional methods to handle this are you either implement strict policies where your teams are only able to create VPCs with very specific images, or you don't allow anyone to create anything that you don't review first, right? Both of these are not ideal. So our aim is to offer security that's verifiable, right, from a compliance perspective and can be imposed at an organizational level without requiring developers to participate in the compliance. Right? Compliance is a problem that, right, as administrators, you have to solve, and that's what GCP is here to do for you. So the organizational policy, and the first one that we are launched again is for the firewall, is something that you can apply at the top of your organization, and any VM or VPC that's created will immediately have it applied. And the way we do this is that when the VM is created, the first set of SDN programming that's pushed down automatically inherits all the firewall policies that are already present in the organization. And again, because of Andromeda-based distributed security service insertion, an organization-based firewall policy can impose security policies on a variety of VPCs while still allowing each individual VPC to solve its own routing, NAT, and reachability problems. And then finally, I just want to quickly talk about secure labels. It's something that we've had for a little while, right? And fundamentally, the challenge has always been to try and offer a less brittle mechanism to identify VM workloads other than IP addresses, which do tend to change. For this, we introduced secure labels. These are tags that are applied in the hypervisor, so they're controlled at an administrative layer. They can't be controlled by individual developers, and those tags travel with the workloads. So you can apply security policy when the workloads migrate. You can apply tags that indicate the source region. You can apply tags that indicate the rights of the workload. And then you can apply security policy that's fairly expressive. So your policy is not brittle, where let's say a new VM was started with a new IP that you didn't include, as Olivier mentioned, then you would have a gap in your system. And so wanted to kind of reiterate that it's these three directions of enhancements that we're trying to build on, right? A robust way, or a more robust way for us to be able to identify workloads to give you a higher level of security metadata. Security built into the fabric, which allows you to insert security processing, which can operate on this rich metadata. And then finally, higher level constructs from a control perspective, organization-wide, project-wide, folder-wide, that will allow you to specify security policy, which will be built in the fabric, which will offer you rich functions like AI/ML-based threat detection, and which takes advantage of this rich metadata in order to provide you a good security surface. So I'm going to hand back to Sid to conclude. Thank you.
Thanks, Ashok. I quickly wanted to wrap up. We have about a minute left. We spoke about network security challenges that you all are facing in the cloud. We spoke about 3 main use cases. We focused on the protection of distributed applications. We introduced cloud-native products that Google offers to solve these challenges. And you must have seen by now how simplicity, how scalability, and efficacy are playing a key role in all of the products that we launch. And finally, there should be no way for you to say that, oh, I need efficacy or I need cloud-like experience. You need to get best of both worlds, and that's what we are offering with all of our network security products. Quickly, I want to make sure that you're able to attend some of the sessions. Sec 301 will talk about cloud NGFW. 219 will go into DDoS attacks for global front ends. 301 will talk about how we are using cross-cloud network as a solution for this problem. And then you have other sessions within the cross-cloud network paradigm as well, like service-centric and so on. Finally, you can use this if you want anyone to kind of help you implement all of the concepts that we have spoken today, please reach out. And finally, give us feedback. We want to understand what worked and how we can make our education and content even better next time. With that, I want to thank the audience as well as thank our speakers for their time. Thank you, everyone.